Okie dokie, here are a couple half-life problems. We'll be using this formula right here. A equals A sub 0, 1/2 T over T. A represents the amount you have left. So if you start with A sub 0, which is the amount you start with, after a certain amount of time, how much you're going to have left. That's A. A sub 0 is the amount you start with. Lowercase t is the time that is passed, and uppercase T is the half-life of the radioactive isotope in question. Now, this particular formula only applies to half-life reactions. So if you're going to do some other sort of exponential growth or decay, you would want to use a different formula, namely A equals A sub 0 e to the kt, but that's beyond our purview here. And also, you can look in 5 different books and see 5 different versions of this formula, but they're all the same formula. They'll just use different symbols for this, or they'll set some things up a little differently here and there. This is the one I'll use right here. Bing, 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 bing. All right, so let's look at an example. Cobalt-60 has a half-life of 5.72 years. How much of a 3.42 microgram sample of cobalt-60 remains after 30 years? They use cobalt-60 in medical treatments. Cobalt-60 decays through beta and gamma radiation, and they can use that gamma radiation, if it's targeted well enough, to destroy cancer cells in the body. So, here we go. So this is a basic question right here. We're going to just use this formula straight away. There has to know how much remains, which will be A. All right? So we can just plug this stuff in. So A, which is what we're looking for, is going to equal how much we start with, which is 3.42 micrograms. And let's see, that's going to be 1/2. Lowercase t is how much time has passed, which would be 30 years. So that's 30.0 divided by the half-life, which is 5.72. Now you have to make sure that your t and your lowercase t are both in the same units, and they are, years and years. So if this were seconds or minutes or what have you, or hours, you have to make sure that they're both in the same. Excuse me. You know, I really should cut that out and redo this, but the fact is I've got a cold, so I'm probably going to sneeze again. So there's no guarantee that if I tried it again, I wouldn't sneeze. So I apologize for that. We're back on track. So now it's just a matter of doing the calculation. So I'll whip out my handy dandy calculator here. This is the HP42S app, a loving recreation of the actual HP42S calculator that I had in college by Byron Foster. So I encourage you to check that out if you have any interest in this calculator at all. It's superb. But it's the one I've used for decades now. So anyway, we need to do this here. Now, your calculator will work a little differently, but there should be some mechanism on your calculator that lets you plug in a number, in this case 0.5 or 1/2, and put it to any power you desire. Mine is that button right there that says y to the x. Yours might say y to the x or x to the y, or it could just have a caret symbol on it, so you type in 1/2, caret, but whatever, it's going to vary from calculator to calculator, so just consult your manual for that. All right, so now let's go ahead and calculate this. If this is all true, and it is, we just need to do the math. So I will take 3.42, enter that, good. Now I will take 0.5, good, I will enter that. Now I will take 30.0 and enter that, and 5.72, good, and I will divide those two, divide. Now I want to take y, 0.5 to the x, which is, I have y to the x, so I will just go kaboom, pow. And now I will multiply that by 3.42, so press multiply, bingo. Looks like my answer is, the amount left over will be, now I've got to account for sig figs, so I have 3 sig figs. The 1/2 doesn't apply here, so I need 3 sig figs in my answer. That should be 9.02 times 10 to the minus 2 micrograms of cobalt-60. There you go. There you go. Doesn't get much more straightforward than that. The tricky part will be when you're having to solve for t or lowercase t, uppercase t or lowercase t. Yes. Okay. Now Now, if you had to solve for a sub 0, you would just divide everything by 1/2 t over t over here. Be done. So let's look at a little more complicated one. Let's try this one right here. A piece of wood taken during an archaeological dig is found to have a carbon-14 content only 0.636 times that of wood cut today. Estimate the age of the wood. The half-life of carbon-14 is 5,730 years. Carbon-14 is a naturally occurring isotope, but it only occurs in living things. So once something has died, the body stops producing, or the body or whatever that thing is, stops producing carbon-14. So if we look at how much carbon-14 is left, and knowing the half-life of carbon-14, we can get an estimate of the age of something based on its carbon-14 content. So that's the idea behind this whole process. So we have a chunk of wood, and it's 0.636 times that of wood cut today. Estimate the age of the wood. So let's see what we know and what we don't know. Okay, we know A. We do not know a sub 0, or do we? I'll get back to that in a second. Lowercase t, that's what we're trying to figure out. So we don't know that at all. And uppercase t is 5,730. 5,730. Now, as far as a and a sub 0, this is telling me that I have 0.636 times the amount found today. And if the amount found in a fresh piece of wood is our standard then for what this wood used to have when it was alive, then we can make a guess on how much we must have started with. And you can pick any number you want here. I'm going to use 100. That's the typical thing. If you have a percentage of something, which that is, just choose 100. That means I have 63.6. So if I started with 100 grams, okay, the units here doesn't matter, and that means after so much time left, I would have 63.6 grams. You could start with 1 gram and you'd have 0.636, or 1,000 grams have 636. However you want to do it, you're going to get the same answer. So if I have a percentage like that, I can assume my initial starting amount and I'll just pick a number that makes the math nice and easy. There it is. Bing, bing, bing. Okay. Now, some people like to do their calculations as they go. I do not. Whenever possible, I like to save all my calculations to the end. So that means for this formula here, I want to solve it first for lowercase t, so that I have lowercase t equals everything else. Then I'll plug in the numbers and solve it. And this is where things can get kind of tricky. So let's do that first. I'm starting with a equals a sub 0. So a equals a sub 0, 1/2 lowercase t uppercase t. I want to solve for lowercase t. So the first thing I'm going to do is divide by a sub 0. So a over a sub 0 equals 1/2 t to uppercase t. Now, I have an exponent. The variable I'm searching for, trying to isolate, is an exponent. So I only have really one method to get rid of that exponent and get it out where I can work with it, and that's to use a logarithm. And you can use any logs at all. I'm going to use the natural log, which on your calculator is a button labeled LN. LN. You also have a button on your calculator called log. Either one of those two will work. I'm going to use the LN button here. And so what I'll do is I will take the natural log of both sides. So over here I now have the natural log of a over a sub 0 should be equal to the natural log of 1/2 lowercase t uppercase t. Now why that helps me is one of the properties of logarithms. If you don't know anything about logarithms, you'll have to take my word for it here, but you might want to look into it. Logs are pretty amazing things. And we have a guy by the name of John Napier to thank for them some 400 years ago. So what this log lets me do, if you're taking the log of something that has a power, I can take that exponent and pull it out front and treat it like a coefficient. So that means I can write this as ln of a over a sub 0 equals lowercase t to uppercase t of the natural log of 1/2. So I can take that exponent and just pull it out. Now it's a coefficient on the log. There you go. That's pretty amazing, don't you think? Yes, I think you do. Okay, so I just want to solve now for lowercase t. So what I will do is I will divide by the natural log of 1/2, and then I will multiply by capital T. So that means finally lowercase t should equal capital T times the natural log of a over a sub 0 divided by the natural log of 1/2. Excellent. Now I can plug in what I know, so I'm ready to go. So t equals capital T, which is 5,730. The natural log of a, which is 63.6 over 100, all over the natural log of 1/2. Okie dokie. That means t must equal, let's get out the calculator now. Again, your calculator will calculate things slightly differently from mine, but all the buttons should largely be the same. It's just a matter of how it's done. So I will take 5,730. I will enter that. Now I will take 63.6, enter that. I will take 100 and divide that. Okay? Now I will take the natural log of that. Boom. There it is right there. Now I will take 0.5 and I will take the natural log of that. Boom. Now I will divide those two. Divide. Boom. Now I will take that, multiply it by 5,730. Pow! Looks like my answer will be how many sig figs? I should have 3 sig figs. So 3,740 years. Wonderful. Give or take a couple decades, I guess. All right, very good. If you have any questions, you know how to reach me. All right, thanks very much.